All right, this is part 2 of our geometry review. This is what, test 1 through 20? 1 through 20 are quarterfinal, so I'll put it up here. Okay, just so we know what we're working with. All right, so we want to find the perimeter of a rectangle. And it is interesting to see how many students confuse area and perimeter in rectangles. The assumption, I think, very quickly becomes, oh, I know what I'm doing, and before we think about what it is that we're doing, we've already written something down. Okay, so we can take something like, I don't know, 39.6. Let's clean that up. And, I don't know, 52.3. Okay, we just want the perimeter, so what do? Add up all the sides. Okay, so what is it?
3 plus 52.3 plus 39.6 plus 39.6.
Okay. I don't know what those numbers come out to. You could also have done 52.3 times 2 plus 39.6 times 2. Okay. Again, I'm not super concerned with what the actual answer here is so much as you know what it is that you need to do to find the perimeter, and that you're slowing down enough to know that you're not just going to very quickly write 39.6 times 52.3, because one of the available options will be that solution. And so you'll think that you got it right because you got something that actually shows up on the test. Okay? But it's a trick meant to catch people who aren't slowing down enough to know that what they're finding is the area and not the perimeter that they're asking for. Okay? All right. Number 9. Okay? We want to write a statement as a biconditional. Have we seen a lot of biconditional statements? Can anybody tell me what a biconditional statement is? No? No, a biconditional statement. So if we're going to write the statement as a biconditional. So basically what a biconditional has is it has this is true if and only if this is true. Have we seen that at all? If and only if? Yes, should have. Okay, so let's see. Give me a type of angle. Okay, so we would say a, let's see, a right angle is an angle that measures exactly 90 degrees. Okay, we want to write this as a biconditional. So we would say an angle is a right angle if and only if it measures exactly 90 degrees. Okay, but it has to have the if and only if in the middle of it. So it doesn't start with if, it doesn't have a then in the middle. It has if and only if in the middle, and it's a correct statement. Okay? But it has to be a true statement. So basically we get Biconditional statements, if a conditional statement is true and its converse is true. So if the converse and the conditional statement itself is true, then we know that we can write a biconditional. So by looking at a right angle as an angle that measures exactly 90 degrees, the converse of that would be if an angle measures exactly 90 degrees, then it is a right angle. Is that true? Oddly quiet. Okay, if an angle measures exactly 90 degrees, then it is a right angle. Okay, so because both what we saw here and the converse are true, then we know that the biconditional statement can be written. Okay? All right. Okay? 10. This should be somewhat familiar to us. That it is. It is the Pythagorean theorem.
Can I go to the bathroom while we're on like an easier question?
Could you say that a little louder so we get that recorded for posterity? The student would like to know if he can go to the bathroom while we answer this question. Why, yes, you can. Well, I should like list the name and everything. Sure, sure. Okay. Yes, but I don't believe the one on the test is. Okay. Because I just picked out two numbers. So yeah, it would be like basically what we would try to do there is see if we could reduce both numbers by the same thing to get it down to like, in fact, no, because 36 isn't a multiple of 5. So no, this is not a Pythagorean triple. Okay. So let's see, Anthony, what do we need to do here? Okay, a squared plus b squared equals c squared. Can you tell me what I'm going to substitute in for c? No? All right. Do you know what c represents? Well, I mean, somebody can whisper that to you, but that doesn't mean that you know it. So, do you know what the c represents? No. Okay. C is the hypotenuse. Always. Okay? Do you know which number up there represents the hypotenuse? 36. Okay? So that's why that goes there. Okay? And only one number is the hypotenuse. All right? Chaparro, what do I fill in with the rest of it? 24 squared? What? Oh, okay, 24 under a squared, and then just b squared for b. All right. What do we do next, Caden? Square them. So what's 24 squared? I don't know. This probably won't come out all nice and neat. What's that? 576 plus b squared. And 36 squared is what, Jewel? 1296. Okay. Reagan, what do you do now? Very good. Subtract 576. Okay. So we got b squared equals 1296 minus 576. 720. Okay. And finally, we would square root. This one probably isn't going to come out to a nice, neat square root. Okay, this might not be a bad time to show you guys how to simplify radicals. How many of you are familiar with simplifying radicals? 1, 2-ish. All right, so not that you're going to need to do this on the test, but it's not a bad skill to have, is to break a number down into primes. So we can take 720 and divide it by the prime number 2. We would get something like 360. Okay, you could take 360, divide that by the prime 2, and you'd get 180. 2 would get you 90. 2 would get you 45. 5 would get you 9. And you'd get 3 and 3, right? So because it's a square root, I'm pulling out pairs. 2, 2, and 3. So that would be 2 times 2 times 3. What's 2 times 2 times 3? 2 times 2 is 4. Okay, so that would be 12. And then I have a remaining 5. Okay, with nothing next to it. Okay, so the square root of 720 is simplified down to 12 radical 5. Okay, again, you probably won't need that for this one, but you'll need to know it later on. Okay. Let's see, that's 10. We need 11. Okay. Okay, determine the midpoint. Let's see. Somebody give me some coordinates. Numbers. Just throw out some numbers.
4, maybe 2, 6, maybe 8.
Okay. All right, midpoint formula is what again?
Over 2. Well, y1 plus y2 over 2.
Okay, very good, Tatum. Tatum, why don't you go ahead and put that information in our formula for us? I'm not letting Garrett talk this time. Okay?
Just for the x1 plus x2.
Yep, let's do x1 plus x2 first.
So negative 4 plus 6.
Okay? Sure, let's go ahead and get the y's.
Negative 2 plus negative 8 over 2.
Okay? Let's try to simplify. What's negative 4 plus 6? 2. 2 divided by 2, which is 1. Okay. What's negative 2 plus negative 8?
Negative 10 divided by 2. Negative 5.
Okay. So my coordinate is 1, negative 5. Good. We got that down? All right. There's a question in here that was on your last test. It's going to say, I'm not even going to write it down. Okay? No, it's going to be, it's going to show you 2 parallel lines cut by a transversal. It's going to ask you what angles, if congruent, prove that the 2 lines are parallel. Okay, so you need to know things about, let's see, alternate interior angles. Okay, alternate exterior angles. And what other? Corresponding angles, right? I heard somebody say same side. The only thing is that we're not going to use same side interior angles. The reason why is because same side interior angles don't have to be congruent to prove that 2 lines are parallel. They only need to be supplementary. Okay, so it's these 3 sets that if my alternate interior angles are congruent, then I can prove the 2 lines are parallel. If my alternate exterior angles are congruent, then I can prove 2 lines are parallel. If my corresponding angles are congruent, I can prove that the 2 lines are parallel. Okay? But here's the thing, is that I can't have, say, this angle and that angle. Even though I know they're vertical, it doesn't tell me anything about that line. Okay? So one of the key marks that we'll see is that it's going to have to be an angle that's going to touch either of the two lines I'm trying to prove are parallel. About dropped this, so that's why I freaked out. Okay? You hear it in the video. Yeah. Do that. Okay. All right. So interior is going to be, it's sandwiched between the parallel lines. And so later on, it'll seem confusing, but you'll get to see parallel lines like that, where in this case, those two are the parallel, or are the interior, okay? So just because it's been rotated around doesn't mean that they suddenly become exterior, okay? All right, this stuff comes from lesson 12. So if you want to look at your lesson 12 notes, all right, I'm just not going to go through it all again, okay? And I want to say that 13 does the same thing, and it's 12 and 13 are the same questions that were on your last test. What 13 is going to say is it's going to say, if this angle measures this, then what does this other angle measure, okay? So you might have to know something about linear pairs, okay, and then use what you know about corresponding angles or alternate interior, alternate exterior, that type of thing. Okay, so I'm going to skip down to question 14. I mean, really, you could probably go back and even watch the review from the last test to catch those questions. You'd see a lot more in there. This one, there's a counterexample question, which is a lot like the last one that you saw, so that's not really any new information. All right, here's a good one, 15. I just don't feel like a question that we've covered on a previous test that I need to go back over. All right, so let's say you have a slope. Somebody give me a fraction. How about -5/8? Somebody give me a set of coordinates. -2, 3. Okay. So with that, you need to be able to write the equation of the line. Okay, here's another formula you need to know. Does anybody know what you use for that when you have slope and a point? Is that not one you know?
No.
Okay, well, it's one you need to know. This is called point-slope formula. So if they give you a point and a slope, then we take what they've given us and we plug it into this formula. All right, so with that, m is my slope, correct? Right, and then I've got an xy coordinate. So the xy coordinate is going to go in for x1 and y1. All right, so I got y minus what? What do you think, Reagan? Okay, y minus 3 equals what? -5/8 x minus -2. Okay, a big mistake there will be the assumption that, okay, well, it's just -2, right? They'll put a plus in there, right? But it is minus -2, which is going to cause what to happen there?
It's gonna turn positive.
Okay. All right. Caden, what do you do with this at this point? Do the parentheses. So x plus 2. What does that simplify to? Oh, distribute. Okay, good. Distribute. Okay, go ahead. Tell me what to do. Okay, -5/8 times x. What's that come out to? -5/8 x. Very good. And -5/8 times 2. Okay. What's -5 times 2? Yep. -10. And what's negative? So we would get -10/8. That'll probably reduce though, right? That would be what, -5/4? Okay. So I'm going to go ahead and write that as negative 5/4. What's next? Add 3. Okay, so we got y equals negative 5/8 x. Okay. Negative 5/4 plus 3. What do I need to do with 3? Could I get a common denominator there? Okay, what would I have? What's the common denominator? 4, so I need to get that 1 to be a 4. So what do I need to multiply 3 over 1 by? 4 over 4. Okay, so I have negative 5/4 plus what? What's 3 times 4? 12/4. All right, so what's negative 5 plus 12? What's 12 minus 5? 7. So it'll be 7/4, right? So negative 5/8 x plus 7/4. Okay, let's see, we're ready for 16. Okay. Okay. Somebody besides Garrett, give me some coordinates. Numbers. Jewel, pick a number. 4. Caden, pick a number. 7. Paro, pick a number. 6. Kaleo, pick a number. All right. Slope. What formula?
Over x2 minus x.
Okay, good. All right. Anthony, plug him in for me. What's y2? Okay, that's fine. You can, I mean, which one do you want to say? 7? All right, so 7 minus what? Okay. Over? 4 minus 6. Okay. What's 7 minus 0? 7. What's 4 minus 6? 2. Or negative 2, right? So it would be negative 7/2 is the slope.
So you can do y1 minus y2.
Yep. So long as you can do y1 minus y2, so long as you do x1 minus x2. Okay. It will come out the same, I promise you. Okay. 17. Okay. Let's see. Determine the conclusion. What's the conclusion to that statement?
Then r.
Just R. Okay. What's the hypothesis? Q.
So what is then?
It just begins. It's a beginning part, so I know where the conclusion begins. Not necessarily filler.
Trick word. Yes, but
Okay. All right. What time are we out of here?
57. You got time.
Oh gosh. Write the. Write the contrapositive of if A then B. Yep. All right, so I heard somebody say if B, then A. That's the converse. What does the inverse do? Converse and inverse. So if what? What does the inverse do? Converse switches B and A. What does inverse do?
It switches to F.
No. No, that's biconditional. Inverse does what? You're going to get a bunch of these questions, so I think you got at least 2 questions before this where you have to know what the inverse is. If what?
Will it throw another letter in?
Throw something else in. Doesn't throw another letter in. You're thinking a syllogism. No. Boy, we're just using words now. Pythagorean theorem? No.
A squared plus B squared then equals.
If not B, then not A. Okay? Where this is equal to the word not. Okay? Inverse applies negation. Contrapositive uses both the converse and the inverse. So it flips B and A and inserts negation. 19. I'm just going to go till the bell rings. Let's see. Okay, in triangle ABC, angle A equals 42, angle C equals 36. Find the measure of angle B. How? Add 36 plus 42. 78, 180, minus 78, 102. 102. Okay. Last question. We got a right triangle. Okay. Let's say ABC. Angle A and angle C are acute. If angle A equals 23 degrees, what is angle C? Right triangle ABC, angle A and angle C are acute. If angle A is 23 degrees, what is angle C?
One degree has to be 90.
Which one?
90 plus.
Is it B?
Angle B is 90 degrees. So here's the thing, is that 23 and C will add up to 90. So I could just simply take 90 minus 23. Okay? And that's it.
Why did you do that?
Because it's faster.
But you still could take.
You could still do exactly what you wanted to do. Yes, you could take 90 plus 23 and subtract it from 180. You'd still get 67 degrees. But the two acute angles on a right triangle will always add up to 90 degrees. Because you have a 90-degree right angle, right? So 180 minus 90 is always 90. Okay? So you can always subtract the acute angle from 90 and find out what the other missing angle is going to be. All right, we're going to stop right there.